example number 7. So Semenov describes some of the chemistry of allyl chlorides. The two reactions of interest in these examples are, first one, which is chlorine reacting with propane to produce chloropropane plus HCl, and the second reaction is that chlorine react with propane to produce dichloropropane. So we can label here, this is our first equation and this is our second equation. So the species recovered after the reaction takes place for sometimes are listed below in the table. So you can see here, sometimes after the reaction has occurred, we still have chlorine and propane, also with our products, which is chloropropane, dichloropropane and HCl with their respective moles. Based on the product distribution, assuming that no allyl chlorides were present in the feed, determine the following, meaning that in our feed, at the initial of the reaction, there were only chlorine and propane. There were no any other chemicals present. So first of all, how much chlorine and propane were fed to the reactor? The second one is that what is the limiting reactant? What is the excess reactant? What is the fractional conversion of propane to chloropropane? What is the selectivity of chloropropane relative to dichloropropane? What is the yield of chloropropane expressed in gram of chloropropane to the gram of propane fed to the reactor, and what is the extent of reaction for the first and second reaction? So let's see how we solve all these questions. So for A, the question is asking us to calculate how much chlorine and propane were fed to the reactor. So let's say if we just draw our process flowchart, this is our feed where we only have chlorine and propane. And then after sometimes the reaction occurred, we still have the unreacted chlorine, the unreacted propane, our product which is chloropropane, dichloropropane, and also HCl. And then I think it's best if we write back our equation. So we have Cl2 plus C3H6 will get plus HCl, and then we have Cl2 plus C3H6, and then we'll get C3H6Cl2. So we know that at the end of the reaction we still have 140 of Cl left and also 651 of propane left. So now we want to find what is the initial. So it would be easier if I write it here. So I can see here that the mole that we have on this product side is 140, and then for propane is 651. So we want to find what is the mole on this side. So we know that the amount of HCl produced is 4.6. We know this one is 24.5 and this one is also 4.6. So if we will just focus on equation 1 first. So we can see here, based on our stoichiometric ratio and stoichiometric coefficient, 1 mole of chlorine and 1 mole of propane will produce 1 mole of chloropropane and 1 mole of HCl, right? So this is our stoichiometric relationship. So from here we can already know that if I have 1 mole of HCl and I have 1 mole of chloropropane, I need 1 mole of propane and 1 mole of chlorine. But in our product side, we know that we have 4.6 mole of chloropropane and 4.6 mole of HCl. So automatically I can know that in order for me to produce 4.6 mole of HCl and 4.6 mole of chloropropane, the mole of chlorine and propane reacted will be equal to 4.6. So I can write here mole of chlorine reacted is equal to 4.6 mole. The same goes for mole of propane reacted. Is equal to 4.6 as well. Okay, this is for reaction A, reaction 1. So if let's say we do the same thing for reaction 2, we have that 1 mole of chlorine and 1 mole of propane will give 1 mole of dichloropropane. And we know that 24.5 mole of dichloropropane is produced. Meaning that in order for me to produce 24.5 mole of dichloropropane, 24.5 chlorine will react with 24.5 of propane. So I can get here for, let's say this is for reaction 1, this is for reaction 2. So mole of chlorine reacted is equal to 24.5 mole, and mole of propane reacted is equal to 24.52. So now I know that this much of chlorine and propane has reacted, so I can find the total chlorine and propane fed to the reactor. So how do I do that? So to find total chlorine is equal to whatever unreacted chlorine I have, which is 141, 141, plus chlorine reacted in reaction 1, which is 4.6, plus reacted in reaction 2, which is 24.5. So I will get a total of 170.1 mole of chlorine. And then to find total C3H6, our propane, the same thing. The unreacted is equal to 651, so 651 plus 4.6 plus 24.5. So I will get here a total of 680.1. So these are the total chlorine and the total propane fed to the reactor. The next one is that what is our limiting reactant and what is our excess reactant. So just now if we look at our stoichiometric ratio, our stoichiometric coefficient, 1 mole of chlorine will react with 1 mole of propane, right, for both reaction 1 and reaction 2. So I know that the total amount of chlorine fed to the reactor was 170.1 mole. So if I have 171 mole of chlorine, I will need 171 mole of propane for a complete reaction. But I know that the total amount of propane that I have is that is fed to the reactor is actually 680.1 mole. So based on this relationship, I can say that my limiting reactant is chlorine. So this is my limiting reactant. And my excess reactant is my propane. It's my excess reactant. So this is the answer for what is my limiting reactant and what is my excess reactant. So the same thing, you can use the extent of reaction to find these two. You will get the same answer. You get that chlorine is the limiting reactant and propane is your excess reactant. So the next one is that what is the fractional conversion of propane to chloropropane? Now if you remember, the equation of conversion is that if you have percent of conversion is equal to mole reacted over mole fat times 100. Okay, this is the formula if you want to find percentage of conversion. But the question now is asking us fractional conversion, so we don't need the percent sign here. If we don't have the percent sign here, we also don't need times 100 on the right hand side. So to find the fractional conversion, we know that the mole of C3H6 reacted. So again, if you look at here, this is referring to equation 1, because only in equation 1 we are producing our chloropropane. In equation 2 we are actually producing dichloropropan. So in equation 1 we know that the mole of propane reacted is 4.6 divided by the total mole of propane fed to the reactor is 680.1. So we'll get a fractional conversion of 6.76 times 10 to the power of negative 3. So this is our fractional conversion. The next one is that what is the selectivity of chloropropane relative to dichloropropane? So selectivity is equal to mole of chloropropane divided with the mole of dichloropropane. Right, simple as that. So we know that from equation 1, 4.6 mole of chloropropane is produced. We divide with, from equation 2, we know that 24.5 mole of dichloropropane is produced. So we'll get a selectivity of 0.188 mole chloropropane over mole dichloropropane. Okay, so this is the answer. Next one, we want to find what is the yield of chloropropane expressed in gram of chloropropane over gram of propane fed to the reactor. So we want to find yield. Yield is equal to gram of chloropropane divided with the gram of propane fed to the reactor. So we have to, if you look at here, we have to find the gram first. So we have to convert all the moles into gram. So we can do it like this. So we have here, let's say, we know that our mole for chloropropane is 4.6 mole chloropropane, and then the molecular weight of chloropropane is going to be 76.53 gram per mole chloropropane divided with the gram of propane. So we know that the mole of propane is 680.1 that is fed to the reactor. Okay, so the total mole fed to the reactor is mole of propane, and then the molecular weight of propane is 42 gram per mole propane. So we calculate and we'll get a value of 0.0123 gram of chloropropane over gram of propane. Okay. The next one is that what is the extent of reaction for the first and second reaction. So again, formula for extent of reaction is equal to the final mole minus the initial mole divided with the stoichiometric coefficient. So for equation 1, you can say that the extent of reaction for equation 1 here, since we already know the product, which is our HCl or our chloropropane, we can just use that value to find our extent of reaction. So it's going to be 4.6 minus 0, because final mole of, let's say, HCl is 4.6, initial mole of HCl is 0, divided by, with our stoichiometric coefficient is 1, so we can get the value of 4.6 mole. Okay, and then for our equation number 2, we can use the dichloropropane we have. So we know that the final mole of dichloropropane is 24.5 minus initial mole is 0 divided by the stoichiometric coefficient is 1. So we'll get the answer is 24.5 mole. So that is the extent of reaction for the first and second reaction.